Hello learners, welcome to another lesson. I'm teacher Alice and we are still looking at the chapter 3 of Form 3 chemistry. It is organic chemistry. So we introduced the topic and we have been looking at the alkanes. So this is part 3 and we are going to look at the preparation of alkanes. So how do we prepare alkanes in our school laboratories? So in the school lab, we prepare alkanes by the reaction that involves what we call decarboxylation of sodium acetate. Sodium acetate is the other name of sodium ethanoate. And we do this in presence of soda lime. Soda lime is a mixture of sodium hydroxide and calcium oxide. Sodium hydroxide having the largest percentage. So in the school lab, alkanes may be prepared through the reaction of a sodium alkanoate with the solid sodium hydroxide, or what we are calling or we are referring to as soda lime. So any alkane is prepared by the reaction between a sodium alkanoate and sodium hydroxide. So this gives two products, that is an alkane and plus sodium carbonate. So those are the two products that we have. So from this reaction here, we can see that a sodium alkanoate reacts with sodium hydroxide or soda lime to give us an alkane. This is the general formula of all alkanes plus a sodium carbonate. So the hydrogen from sodium or in sodium hydroxide is transferred to the alkane to the sodium alkanoate here, and it forms an alkane. Then the carboxylic part here, we have it is transferred to the sodium carbonate, to the sodium to form sodium carbonate. So this right side of the alkanoate joins the sodium to give us sodium carbonate, while the hydrogen in sodium hydroxide moves to the first part or the left side of the alkanoate to give us an alkane. For example, if we want to prepare methane, methane is the first alkane with one carbon atom. So we prepare it by heating sodium ethanoate and soda lime. Then it is collected, the gas is collected by overwater method. The reason is because it does not do what? It does not dissolve in water. So sodium ethanoate plus soda lime to give us methane and sodium carbonate. You can see this hydrogen in sodium hydroxide is transferred, or it moves to the CH3 in the ethanoate to give us a CH4. So then the sodium combines with, so we have first one sodium here and another sodium here, so they form to give us two sodium atoms. Then the carbon and two oxygens plus another oxygen in sodium hydroxide will give us sodium carbonate. So this is the experiment that we set to prepare the methane gas. So we have our flask here containing a mixture of sodium ethanoate and soda lime. Then after we heat, it will produce a gas. This gas will move through the delivery tube through the water to this gas jar here, and this is the method of collection of the gas is what we call over water method. Since it does not dissolve in water, it will be collected through over water method. So the gas that we are going to collect in our gas jar here is methane gas. Then in this flask now, we are going to have sodium carbonate. So the final products will be sodium carbonate and methane gas. So that is how we prepare methane. Let us see how we prepare ethane. So ethane is then prepared by heating a mixture of sodium propanoate and soda lime, and also it is also collected by over water method. So it means these gases are collected by over water method. All of them do not dissolve in water. So even if we come to propane or butane, they will also be collected by the method over water method. So the reaction is here. We have sodium propanoate plus soda lime to give us ethane and sodium carbonate. So CH3, CH2, COO, and Na, that is sodium propanoate plus soda lime or sodium hydroxide, to give us ethane and sodium carbonate. So ethane is an alkane with 2 carbon atoms and 6 hydrogen atoms. So the hydrogen in sodium hydroxide moves and it joins the CH3 in the sodium propanoate to give us an ethane. Then the sodium and the oxygen then joins with the second part of the sodium propanoate to give us sodium carbonate. So that is how we prepare. This is the experiment here. We have a mixture of sodium propanoate and soda lime, and we must heat for the reaction to take place. So we produce a gas, ethane gas, collected. It is delivered through this delivery tube to the gas jar, and we collect it through over water method. So this is how we prepare ethane gas. Sodium propanoate and soda lime. We have said soda lime is sodium hydroxide. So make sure you can write the correct formulas of the alkanoids. So for the propanoate, that is the formula. And something else we note is that if we want to form an ethane, we are picking the alkanoid that is above ethane. So after ethane, we have propane. So the alkanoid will be propanoid. So if we want to prepare propane, we are going to use an alkane that is below, or that is above the propane. That will be the fourth alkane. That will be sodium butanoate. All right, that is the trend. So we have a question here. It asks, the first question asks, write the balanced chemical equation for the preparation of methane from sodium ethanoate and soda lime. So now when you're told to write the chemical equations, you must know the correct formula. So this is the correct formula of sodium ethanoate. So for if it is an ethanoate, so it is ethane is only 1 carbon atom. So the other part is just adding a C double O and an Na for the sodium. So sodium ethanoate. If it is for propanoate, so for the methanoate, so the propanoate, it is 3. So 3 carbon atoms. So it will be CH3, CH2, COO, and then the sodium. So this is the chemical equation for the reaction between sodium ethanoate and soda lime. The second question asks, explain why it is necessary to collect a methane gas or by over water method in the laboratory during the preparation. So why is it necessary that we collect this one through the gas through over water method and not any other method? So we say methane gas is collected by over water method because it is less dense than water and it is insoluble in water. So those are the two reasons why we use over water method. One, it is less dense than water and it is insoluble in water. This ensures that this gas can be easily collected without dissolving, therefore allowing for the accurate measurement and collection of the gas produced. So if you are told just to state the reasons, just say it is less dense than water and it is insoluble in water. But if you are required to explain, you have then to continue and say the method ensures that the gas can be easily collected without dissolving since it is insoluble, and it also allows accurate measurement and collection of the gas that is being produced. Right, so those are the two questions that we are going to answer, and that marks the end of part 3. So in our part 4 now, we are going to start looking at the physical and chemical properties of alkanes. So let's meet in our next lesson.